So how do we name ionic compounds? Well, first of all, we're going to talk about binary ionic compounds, which means two-part, two elements. And it's always got a cation and an anion, and they're always named in that order, cation and anion. And so for the example of sodium chloride, the cation is sodium, the anion is chloride, and when you name them, you simply name the metal, which is sodium, and then you name the anion by changing the ending to IDE. IDE, so it becomes, instead of chlorine, it becomes chloride. All right, and you usually don't include the number of atoms that are in the name. So in other words, magnesium chloride will come from a magnesium 2+ ion and chloride -1 ion, but those two do not balance charges. You have a 2+ and a 1-, so magnesium chloride will have 2 chlorines, and it will be MgCl2. But notice that the name in no way indicates that there's 2 chlorines. You have to know the charges to realize that it would have to have 2 charges. And would have to have 2 chlorines. All right, so let's practice. K2O would be named what? Well, you name the metal, potassium, and then for the non-metal, you simply name it and change the ending. So it was oxygen, it becomes oxide. And I think this is written wrong. It still means name. Name it. CaF2 would still simply be calcium fluoride. Okay, but you can do writing the name formula for something. So let's pick one. Let's make it sodium oxide, and you try to write the formula for it. Okay, well, you need a sodium, which is a single plus, and oxygen, oxide, is 2-. Therefore, to form sodium oxide, you would need 2 sodiums. So sodium oxide would be Na2O. Again, you need to figure out the charges to know how many of each are on them. The name does not tell you. Okay, but there are some examples where, or some exceptions, where you do have to name how many, and those are metals that form more than 1 ion. Okay, group 1 only forms +1, group 2 only forms +2, but there are some elements that can form more than 1, and iron is one of them. It forms Fe2+, it forms Fe3+. So when you are combining it with oxygen, the Fe2+ version would be FeO. Because you have a 2+, you have a 2-, they would combine in a 1-to-1 ratio. And that would be iron oxide, right? And the Fe3+, when it combines, you would need 3 oxygens, and you would need 3 irons, so 3 oxygens and 2 irons. And some people like to think this as crossing these over. The 2 goes here, the 3 goes here. Although notice up here, if they're 1-to-1, they stay 1-to-1. Okay, so it becomes Fe2O3. Now both of these are iron oxide, but one's with Fe2+, one's with Fe3+, so in the name, we include Roman numerals, and we say iron 2 oxide because it's a 2+. Okay, so it comes from the 2+. So in other words, when we have this case, we use Roman numerals to indicate charge on the cation. So this one would be iron 3 oxide, and the Roman numerals go in parentheses after the metal name. All right, and there are certain metals that I'd like you to know have more than one charge or oxidation state. and these are the most common ones. So chromium could be Cr2 plus or Cr3 plus. Iron, which I just did, can be 2 plus or 3 plus. Copper can be 1 plus or 2 plus. Lead will be 2 plus or 4 plus. And finally, tin can be 2 plus and 4 plus. So these are the most common ones. All right, so try one problem. Try to name this compound. Okay, again, put down the metal, put down the and chlorine with an IDE ending, but it's got to be copper 2 chloride, because copper is one of them up here that can have more than one oxidation state. All right, but those were binary names. Okay, binary names with and without Roman numerals. And the Roman numerals are only needed for those that have more than one common charge. But now we can talk about ones that are not binary. They have polyatomic ions, so more than one atom in their ions. And we treat the polyatomic ions as a unit, okay, a single unit that doesn't break up. And it turns out, and so let's give an example. SO4 2 minus is a polyatomic ion. And so we keep it as a unit, SO4 2 minus. We don't break off an oxygen or anything else. Within this polyatomic ion, there is covalent bonding, but between that ion and a cation would be ionic bonding. Okay, so you need to learn the names of the common polyatomic ions and their charges, but let's first talk about how they go together. Whoops. All right, so let's first back up. If you have potassium and chlorine and you want to form a compound, they're a 1-to-1 ratio, so it's just KCl. Okay, if you have potassium and a polyatomic ion, NO3 minus, it's still a -1 charge for that whole polyatomic ion, so you still combine it in a 1-to-1 ratio, and you would have potassium nitrate. So we learn the name nitrate refers to NO3 minus. That's how you name it. It's also possible for the cation to be a polyatomic ion. This is ammonium. So you can combine that with nitrate. It's a 1-to-1 ratio in charges, so it's simply NH4NO3. You could write it a different way. You could write N2H4O3, but we're going to write it this way, and it is ammonium nitrate. Okay, so you simply put the polyatomic names together. The reason we're not going to write it this way is because it's not obvious that it's this set of polyatomic ions. All right, and then again, as we said before, your charges aren't necessarily going to balance. These are all 1-to-1. But let's look at magnesium combining with nitrate. Okay, you need 2 nitrates to do that. Okay, but we aren't just going to write MgNO3. We need 2 of them. And the way to indicate that, I'm going to delete that. The way to indicate that you have more than one polyatomic ion is you need to put parentheses around the entire polyatomic ion. Okay, so we need 2 nitrates, so we put parentheses around the whole thing and another subscript. So we need 2 nitrates, but the whole thing again. And that would be called magnesium nitrate. So you can have more than one polyatomic ion, but you must put parentheses around the whole thing. Okay, so what are the most common polyatomic ions? There's only one that commonly used cation, and that's ammonium. Most of the polyatomic ions are anions. All right, so I'm gonna divide them up into ones that have a -1 charge, a -2 charge, and a -3 charge, and I'm gonna write them all here. OH minus is hydroxide ion. NO3 minus I've already done. nitrate. There's one similar, NO2-, which is nitrite. We have Cn-, cyanide. MnO4-, which is permanganate. And finally, CH3COO-, and that is acetate. Okay, those are not all of them, but they are the most common. In the 2- category, we have CO3 2-, which is carbonate. We have SO4 2-, which is sulfate. And another similar one less oxygen, just like we did for nitrate, one less oxygen, was nitrate, nitrite. This is sulfate and sulfite. Then finally there's Cr2O7 2-, which is dichromate. Okay, and in the 3- category, I'm simply going to list PO4 3-, which is phosphate. So those are the most common ones.